MacMaths. Let's do some maths today. Statistics. Okay, guys. So this is chapter 3 of the A.E. Pearson AS book, and actually, it's mostly, when I look at it, is GCSE stuff. It's just box plots, cumulative frequency, curves, and histograms, and then there's a little bit at the end about comparing data. So it is still worth watching them, I think, just to remind you if you've not done them since GCSE, as I just sort of go through them and remind you what they are. The comparing data, it is just say what you see, and students struggle with those sorts of questions, so it's definitely worth watching the ones at the end. And then there's a little bit at the beginning which isn't really, it's not covered in GCSE, it's really basic, but it's just about identifying outliers. So I'm just going to go through that now very quickly and just do a couple of questions from exercise 3A, okay, and then we're done. Okay, so that's what we're doing. We're going to identify outliers. So mathematicians, when they're identifying outliers, there's a couple of ways you can identify. You've got data, and you can identify outliers in a couple of ways. If you remember, which is actually going to be lesson 3B, is box and whisker plots. Okay, so if I just remind you of box and whisker plots, box and whisker plots are based on position, aren't they? Okay, so we have the position. You draw it just to represent the median. Okay, the median is always that line in the box, and Q2 is a way of describing the median because it's the middle quartile. Okay, this line here is Q1 and this line is Q3. At GCSE you would have called this the lower quartile, and this one the upper quartile, of course. And then of course this is the median, isn't it? Okay, and so this distance here, between each, this is the biggest value, the biggest, and this is the smallest value. So you draw them on a graph paper, don't you? Okay, so that's a box and whisker plot. This distance here, between each line on your box, is 25% of the data. So 25% of the data values fall in that range. 25 in this range, 25 between the median and the upper quartile, and 25 between the upper quartile and the biggest value. It's split in. A box and whisker plot splits the data into 4 values. Usually this middle bit is sort of narrow, isn't it? Because most of the data tends to be, for most distributions, in the middle, and then these are quite far out because, you know, data sort of spreads out as you get near the edges, okay, of the universe there. Okay, so identifying outliers then. Well, if you're dealing with the median, this here is the interquartile range, the distance from the lower quartile to the upper quartile, the IQR. You'll see it in the A-level book as written like that, Q3 minus Q1. Okay, that's how you calculate it. So mathematicians will often use amounts of this above quartile 3 or amounts of this below quartile 3. They'll call it in the back K, in the book, sorry, K, Q3 minus Q1. And K indicates the rule of how they're going to describe an outlier. They seem to go with 1.5 commonly. They may go with 2 depending on the data and so on. Okay, so that is up to a mathematician to decide, and they will decide for you and tell you on the exam. So if it's 1.5, what they're saying is that we're going to describe anything with an outlier, anything as an outlier, if it is 1.5 times bigger than this spread above the upper quartile, or 1.5 times bigger than this. So if you think of like 1.5, that's about there, about there. So anything above here, any bits of data would have been an outlier, and 1.5 times that distance here would have been about here. So any data values above or below this then would be an outlier, and this is the rule that would be used for that. They might even go 2 lots, so it might have to be further out to be an outlier. That means that when you're drawing your box and whisker plot, okay, when we have our biggest value, say your biggest value was up here, instead of drawing your whisker up here then, Okay, what you would do if you were following this rule and it was 1.5 times, and your top whisker for your biggest value was up here, what you would do is you would then work out the limit, okay, and put your whisker there. Now that tells you that anything bigger than that is an outlier, and then you put a cross in to say that that point there is the limit of anything bigger than that is an outlier, and that is an outlier, so you put the data values in, okay, and so on. So that's how you do it for box and whisker plots. For means and standard deviation, they do the same sort of thing. So you've got a spread of data, so data goes here, your mean is somewhere in the middle usually, isn't it? You know, somewhere around this region. And you've worked out the standard deviation, and you've got a value for the standard deviation there, okay, and this value here, they'll say something like plus or minus, you know, 1.5, do same here, standard deviations, okay, or plus or minus 2 standard deviations. So once you've worked out that standard deviation, if that is a standard deviation takes you this far above the mean, then 1.5 lots of that takes you to about there. Any data values above that, okay, it would be classed as an outlier. Anything, if I go 1.5 from the mean, anything within this region, a data value within this region from the mean, okay, above or below, is a legitimate piece of data. Anything outside of that would be classed as an outlier, okay. But again, in the book, they will give you the rules for that, and that's basically it. Really, really simple, isn't it? So let's just do a couple of questions from exercise 3A. Have a go first. I'm sure you'll get them all because they're really, really easy. But I'll go through them. There is the question. There's only 4 questions in exercise 3A. I'm not going to do them all. I'm nearly. I'm just going to miss out question 2. Okay. So question 1, really simple. Tells you Q1 is, get my calculator here. I haven't pre-done these. Okay. So it says Q1 is 46, Q3 is 68. An outlier is 1.5 lots of Q3 minus Q1. Okay, so take away that. The interquartile range, or you'll see it written like this, Q3 minus Q2 is equal to 22. Okay, so 1.5 lots of 22 is times by 1.5. Oops. Shouldn't really do that there, should I? That's the interquartile range. An outlier is 1.5 times 22, which gives you 33. So 33 above the upper quartile, or 33 below the upper quartile. So it's an outlier then if it's 33 above this. An outlier then is greater than, let's add 33 onto that, 71, 81, 91, 101, greater than 101, or less than, let's take 33 off the lower quartile, so that would be 13, less than 13. Okay, so it's an outlier of these, and it gives you 3 numbers, and it says, are any of these outliers? Yes, A, 7 is an outlier because it's less than 13, and 105 is an outlier, okay? Because it's greater than 101. If you were doing, for this data, we can't see the data, but if you had Q2, there was Q2, we know Q3 is at 68, we know Q1 is at 46, we'd have our box plot, and because there's outliers either end, we'd do our whiskers at 101, and we'd do our bottom whisker at 13, okay? This value here, 105, we'd put as a cross, that would be at 105, and we'd have a little cross at 7 as well to represent this data. 88, you know, is somewhere in the middle, so it's somewhere in this region, so that's fine. Okay, so that's how we would draw a box and whisker plot for that data if we were required to do so. Okay, but we'd need a bit more information. Okay, that makes sense. This one here, the next one is about Arctic foxes, and it gives you that the mean, okay, using a symbol. It says the mean of the Arctic foxes is, I've used symbols quicker to be quicker here, but in the book it says it's talking about the masses of the Arctic foxes and the and it doesn't use symbols, it just uses the words, but I've changed it. So the mean is 6.1 kilograms. Blimey, the small them Arctic foxes. I've got a cat that's 6 kilograms we weighed her the other day. Big fat Nelly we call her. She just wants to eat food all day, so she's on a strict diet now, so she's not very happy. It tells you that the variance, remember that the variance, not much use, is 4.2. And it does say that, so it's getting you to do a little bit of work, because you have to then remember that the standard deviation is the square root of the variance. So the standard deviation is the square root of 4.2, and I'll just work that out because we'll need that for this question, is 2.05. So that is the standard deviation. It says, work out whether these foxes are outliers then. Well, look at it, they've decided to say the definition for an outlier is plus or 2 standard deviations. So double that is 4.1, okay? So plus or minus 4.1, that is 2 standard deviations above the mean or below the mean. So we're going to add 4.1 onto that. So if it's greater than 10.2 kilograms, or it's less than, if we take 4.1 off that, 2 kilograms, then it's an outlier. And we've got these foxes, haven't we? So A is okay. A is okay. Oh, sorry. 2.4 is okay. It's not an outlier. 10.1 is just about okay. 3.7 is okay. 11.5. So we've got an Arctic fox, big fatty there, that's 11.5. That's an outlier. They obviously just caught that one after it had just eaten an Arctic hare and hadn't yet managed to do a poo. Okay, so that was the one. What is the smallest and largest fox that's not an outlier? Well, we had to work out those limits, didn't we? 10.2 kilograms and 2 kilograms. We had to work out those limits in order to say whether these were outliers or not. So, a bit of a silly question, that one. Alright, so that one was number 3, about the Arctic foxes. And there was only one of those Arctic foxes that was an outlier. And number 4 is an interesting one, just because of the last question. It says that 9 people at the children's party, so the sum of the 9 people, the ages of the 9 people is 92, and the sort of squared all their ages and got, oops, and added them all together. The sum of the ages squared is that. Okay, so work out the mean and the standard deviation. Okay, so the mean is the sum of the ages divided by how many there are. So 92 divided by 9. 92 divided by 9 is equals to, SD, 10.2 years old. Okay, quite old for a children's party. 10.2 years old. And the standard deviation, remember the standard deviation is using this sort of summary data, okay, is the square root of that 1428 divided by 9 minus the mean squared, 10.2 squared, okay, remember that. So the square root, where's the square root button? There it is, of that, so 1428 over 9 minus 10.2 squared is equal to 7.4. Okay, so that's the standard deviation, and that's the mean. One age is 30 years old, is an outlier if plus or minus 2 standard deviations, it doesn't use a symbol, is the rule. Okay, so it starts off the next part for part B. It tells you that plus or minus 2 standard deviations. Well, times that by 2, and we've got 14.8. So plus or minus 2 standard deviations is equal to plus or minus 14.8. If we add 14.8 to that, we get 25 years old. Okay, so 10.2, that's the mean, plus 2 standard deviations, which is 14.8 gives you 25 years. Therefore, 30 is an outlier. I hope you can read that. That's fitting on. Okay, so this person who's 30 is an outlier. It says suggest why this could be a legitimate value. Okay, so it's in there. So suggest why it could be a legitimate value. So it could be, see. So this is different than GCSE. It's asking you to comment on the data, isn't it? And you have to think about the data at A level. It could be an adult. Could be one of the adults in charge. There you go. But then it says, given that all 9 are children, clean the data and recalculate the mean and standard deviation. So actually somebody has entered this data incorrectly. I remember in the first chapter we talked about dirty data. In other words, data relies on is only as good as the person putting it in, and somebody has typed in the wrong number here. Maybe they were 3 years old and they pressed a 0 and put them in as 30. So it's telling you now that that is an incorrect piece of data or a data value. And when we clean the data, we take out any bits of data that we know cannot be right. Well, we know that there was no one, this was just the children, so this data is wrong. So we're going to take this out. If we take that out, okay, we've now only got, although there was 9 children in there, we're only going to use 8 of the children to work out the mean and standard deviation, because we know one of the bits of data was entered incorrectly. So now we're going to use n as 8, not 9, for 8 bits of data. We know that the sum of all of the ages was 92, so the sum of x is now, taking out that 30, because it included that, is now 62. And we know that the sum of all of the ages squared was this, so the sum of all of the ages squared now is equal to this minus the data that we had, but it was that squared that was added in, and 30 squared is 900. Okay, so we've now got 528. So that was, you can see what a massive effect that had on that bit of data there. Okay, so that's what it should have been. This is correct data now. N is 8. Now that we've cleaned it up, the sum of those 8 ages is 62, and all of those 8 children, their ages squared, the sum of all of their ages squared is 528. Okay, so now the mean is actually 62 divided by 8. Divided by 8 is equal to 7.75. Okay, so you can see that having an incorrect bit of data really pulled that mean up to 10 years old, when the average child is really, the mean child is only 7 years old, between 7 and 8. And the standard deviation, so it's the standard deviation is the square root of 528 divided by 8 minus the 7.75 squared. Okay, to be recalculated. So again, the square root of 528 divided by 8, and it's minus 7.75 squared. Okay, so the new standard deviation is 2.4. Okay, 2.4 years, not 7.4. So an outlier really is any child that's over double that, 4.8 add on, just over 11, 12 years old, not 25 years old. So that's the effect that dirty bit of data had on our results. Okay, but we cleaned it up, we're all good. Okay, so that was just exercise 3A.